Good morning, good afternoon, good evening, wherever you are in the world. Um, I would like to begin with not with data, but with a simple image. Somewhere right now in a warehouse the size of a football field, millions of tiny electronics pulses are firing, not in brain, but actually in silicon. Every second, billions of tokens are generated, thousands of models are trained, and conversations like this one are unfolding across the world. Most of us really never see this. To us, AI feels weightless, like code, like thought, like magic. But behind every fluent sentence and every perfect image, there is heat, water, steel, land, and electric grid working at full capacity. We have built intelligence, or at least the beginning of it, and we have built it out of matter. So the question in front of us today is not only what AI can do, but what it costs and what it must become if it is to serve people and planet. And today we all explore the hidden physicality of AI, paradoxes that emerge when efficiency fuel demands, and the choices that we determine whether AI become an extractive or sustainable, equitable, and enduring. This is just a technical, well, let's say this is not really a technical lecture. It's a conversation about responsibility, design, and the kind of future we choose to build. So let's begin. You're probably very familiar with the picture when we talk about sustainability, the model of sustainability. Most people immediately think environment, carbon, climate, emission when we talk about sustainability. But sustainability is actually probably understood is far broader than that. True sustainability looks at the world through their independent lenses, not only how we protect the planet, but how we support people and how we structure economies that we endure over time. This traditional model in the green, widely used in policy, science, and development. It has the environmental sustainability when we talk about energy, water, climate, biodiversity, carbon, and footprint. We talk about social sustainability when we talk about equity, well-being, justice, human rights, and labor. And we talk about the economic sustainability when we talk about growth, productivity, markets, long-term value creative. And what's important here is balance. Because if you take any of the two and how they intersect, like environment and social, you get a good society, but may not prosper economically. If you take environment and economics, the intersection is viable, where you get growth is possible, but people may be left behind. If you take the social and the economic, it's equitable, fair, inclusive, but may not protect the planet. So the three of the pillars has to intersect to get a sustainable society where society thrives and the planet is protected and the prosperity is shared. So this is the foundation of sustainability thinking globally, and they apply it everywhere. But when we move from climate science to artificial intelligence, something interesting happens. AI does not impact society and economy separately. It merges the two, affecting labor, productivity, pricing, access, wealth distribution, and governance all at once. So in this presentation, I adapt a different model for AI sustainability, not to replace the traditional pillars, but to show how AI shifts the balance. So where environment concern stands alone, and social plus economic outcome converge into one combined domain of human and institutional sustainability. This reframing helps us ask better questions. Not just, is AI good for the planet, but is AI good for people and the systems that govern work, wealth, and opportunity? So, with that said, AI is progressing at extraordinary speed. Moore's law, and you're probably all familiar with it, is no longer the ceiling. Compute demand is exploding faster than efficiency gains can keep up. And so sustainability cannot sit at the edges of this conversation. It must guide how we build, scale, and govern intelligence moving forward. So we'll talk about the first pillar, which is the environmental sustainability. Even though AI feels intangible, it has a very physical footprint. Training one frontier scale model can consume as much electricity as a small town. Cooling requires millions of gallons of water. Data center clusters around cheap land and power, but local grids often were not built for this level of continuous load. So it has a huge impact on the local community. Yet this is just a problem. This is not really the problem, just the problem. It's also one of the clearest areas of innovation. I mean, there's a lot of innovation going into these areas. We are seeing renewable power data centers, ultra-efficient liquid cooling, edge computing, and model compression. Green AI is technically possible, but only if we prioritize it. The second pillar is the social and economic sustainability. AI can narrow the wealth gap or widen it. And right now, both directions are possible. The global south risks becoming a consumer of intelligence rather than a producer. If foundational models remain controlled by a few nations and corporations, inequality could deepen dramatically. Sustainability here means access, capacity building, regulation, fair compute distribution, and inclusion benefits. It means not just technological progress, but equitable progress. And the third pillar is around human and institutional sustainability. Ultimately, the goal is not to make machines smarter, it is to make societies stronger. Education must evolve for a world where knowledge is abundant, but wisdom is scarce. Institutions must adopt AI without eroding the human purpose, creativity, and agency. We need systems where AI amplifies humanity instead of replacing it. So this is what I call sustainable intelligence, AI aligned with human resilience and long-term well-being. So the real question is not, can AI do more? It is, can AI help us become more capable, more connected, and more human without costing the planet or the people who lives on it much. That is the challenge ahead. We often talk about AI as a progress. Faster model, smarter systems, lower cost, greater capabilities. And all of that is true. Progress is real, it's rapid, and it's transformative. But progress has a shadow. Even a leap of efficiency makes AI more powerful and more accessible. And that means we use more of it, not less. And instead of reducing consumption, progress accelerates it. Instead of shrinking our footprint, it expands our ambition. It is the paradox of what we call the paradox of progress. Let's dive a little bit more into this. What we usually assume is that the efficiency solves resource problems. We think that if AI models become more energy efficient or hardware becomes more optimized, the total resource consumption should go down. Jevons paradox tells us the opposite often happens. In 1860, William Jevons observed that when the coal engines became more efficient, the coal used did not decline. It skyrocketed because efficiency made coal cheaper to use. Industry adopted it everywhere. So AI actually mirrors this pattern almost perfectly. As GPUs improve and the models are optimized through quantization, sparsing, low precision computing, the cost per inference, this does not reduce demand, it accelerates it. What happens next? We run more AI models, we train larger models, we deploy AI into more industries, more devices, more decisions, more life. Efficiency unlocks scale, and scale drives exponential growth in total consumption. This is the paradox of change. Even if each inference become twice as efficient, the number of inferences might increase a hundredfold. Total energy use, chip demand, land use all still rise. More efficient systems often lead to more use, not less use. So efficiency is not the end point, it's an accelerant. The real leverage is in energy source, grid decarbonization, governance, and demand shaping, not just optimization of models and chips. Let's focus on the paradox of the data centers. We often assume that making technology more efficient make it more sustainable. But with AI data centers, the opposite is happening. As the data centers get more efficient, the cost per computation falls, and this drives scale and adoption. We don't run fewer workloads, we run more. Instead of smaller footprints, we build larger data centers that operate continuously, the 5 nines and of availability. Not occasionally, efficiency unlock volume, and volume multiplies total consumption. So even though each computation may require less energy, the total energy and water usage increases, and local grids observe the impact. These grids are not designed for constant hyperscale demand concentrated in a single region. So we see stress on electricity and water systems. And to guarantee uptime, operators rely on fossil, because we don't have enough green energy, they depend on fossil backup generations, which means efficiency leads to more carbon, not less. The key insight is that sustainability problem is not just about power, it's about scale. And beyond electricity and water, there is a hidden load on chips, land, public finance, and network capacity. Data centers pull on global supply chain, local real estate markets, municipal tax structure, and the physical internet itself. The more efficient AI become, the more models we deploy, the more devices we integrate, and the larger the ecosystem required to support that growth. So the paradox is hyper efficiency makes individual operations cheaper, but at scale, it creates unsustainable total consumption. Efficiency accelerates progress, but without systemic change, it can accelerate depletion as well. Now that we see why efficiency does not always reduce consumption, let's step outward from energy and cooling and look at the broader system that AI depends on, which we call the hidden load. Data centers does not exist in isolation. They sit inside the global supply chain, real estate markets, and local economies. And the physical internet itself So as AI scales, each of these domains begin to feel pressure. From the chips, you can see that the prices of chips are actually going higher because everybody's focusing on those GPUs and producing those GPUs. So the actual chips that you use in cars, appliances are not as available. The land where those concentrations of data centers are happening and basically taking farmlands and housing lands and converting it to huge data centers, and it's increasing the land around it and impacting the life in the region. And the local economies, the governments compete aggressively to attract these data centers. Many offer large tax exemptions, sometimes worth billions of dollars, which to attract them, which means infrastructure grows, but tax revenue does not. Actually, if we look at the average data center, it hires around 50 full-time employees per center, which is basically not really a great addition to the local economy, where basically the exemption takes billions of dollars from the tax revenue. And finally, the digital infrastructure. Of course, it doesn't need electricity, only AI. It needs data movement at unimaginable scale. So the volume of information being processed and transferred is measured in zettabytes. And our global fiber and subsea infrastructure is struggling to keep up. So if we do nothing, we may see congestions, reduce access quality, or even a tiered internet where basically this internet, the fast internet, is for the people who pay more, could actually happen. This is why sustainability is much bigger than energy efficiency. To build AI responsibly, we must consider chips, land, local budgets, and network capacity just as seriously as we do kilobytes and water. So now we have seen both the Jevons paradox and the data center paradox, and we can step back and look at the bigger picture. They both point to the same truth. Efficiency does not solve the resource problem. It often amplifies it. So when AI becomes more efficient, the cost per inference drops. That lowers the barriers to usage, and suddenly we run more models, more queries, and more deployment. So the better we get, the more we consume. This is the sustainability paradox. So the solution is not just build faster GPUs, cheaper inference, or better cooling. Those definitely help, but they do not change the curve. True sustainability requires structural transformation, not just optimization. Running AI workloads in renewable power data centers, decarbonization, the grid that feeds them, smart cooling, chip design, model compression and quantization, edge computing to reduce the cloud dependencies, and critically, policy and institutional governance to set limits and guide use. Because efficiency accelerates progress, but only intentional design makes progress sustainable. So if intelligence comes at the cost of our environment, is it really intelligence? That's a very important thing to think about. Now, let's just look at the planetary, which is the first pillar of our sustainability model. If this is where we want to go next, the question is, this is where it gets exciting, because AI is not just a digital phenomena, it's actually a planetary one. Every prompt, every model, every breakthrough touches the earth through energy, water, minerals, land, grid, capacity, and global equity. So we can either build intelligence that extracts or intelligence that regenerates. we can design the future that consumes or the future that sustains. And we get to decide which one we, we become. Here, AI may feel virtual, but it is not weightless. Every query and every model and every breakthrough runs on electricity. And it runs on servers, in buildings, on land, cooled by water, powered by grids. And when we zoom out, we see the scale. Data centers, as you can see on the slide, electricity used today is already around 415 terawatt hour per year, about 1.5% of all electricity consumed on Earth. A few years ago, data centers were a niche load, barely visible in the global energy picture. You cannot see it. Today, they are rising into the same category as the entire industry sectors. The growth curve is not flat, it's steep. If current trends continue, global data centers demand could more than double by 2030, nearly a trillion kilowatt hour per year, roughly comparable to what the entire major nation consumes. So as the AI accelerates, we're not simply scaling software, we are scaling energy systems, grid infrastructure, and planetary resource demand. This is why sustainability enters the conversation here, because intelligence is no longer only cognitive. It's electrical, it's physical, it lives in steel and copper and gigawatts. AI is not just transforming the digital world, it's reshaping the real one. Of course, we did an amazing work on efficiency of computing to help make the compute more efficient. The amount of compute used to train cutting-edge models has been increasing by roughly an order of magnitude every year, not every decade, but every year. Meaning we are scaling AI faster than hardware or software efficiency can offset it. And I need to speed up a little bit because we're not going to be able to finish what we need to finish. But training a single frontier scale LLM can consume as much electricity as powering over 100 homes for the entire year. So inference, the actual usage, the inference is basically when you use those queries, is even more important long term because it happens millions and billions of times every day. So today, an AI prompt consumes about 10 times more energy than Google search. And this is why the data center capacity is forecasted to nearly triple by 2030. We've been working very hard, technical technology companies been working very hard on solving a lot of engineering questions. From 2020 to 2024, NVIDIA achieved almost 4 times improvements in the GPU energy efficiency. That's amazing, extraordinary engineering achievement. Better chips, better cooling, better throughput, and per watt. But now look at the second curve on the slide. Over the same period, almost entirely because of the large language model, the LLMs, to compute required to train frontier scale AI grew not by 4 times, but by 1,000 times. So basically, you got improvements in the chips and the engineering by 4 times, but actually we needed a scale of 1,000 times to train the models. This is really what I wanted to get out of this slide. And the efficiency curve dynamics, basically, when we talk about for 60 years, computing has followed a beautiful curve. every 18 months, we get twice the efficiency for the same energy. And that has been happening for the last 60 years. Data centers today waste far less power than they did a decade ago. Cooling systems are smarter, chips are denser, power utilization efficiency is dropping. We are genuinely improving. So why isn't it our power consumption is going down? Because every step of efficiency unlock a new capacity, and that capacity gets filled almost instantly. Faster hardware, you get bigger models, better power efficiency, you get more racks built, cheaper compute, you get higher usage. Each improvement fuel demand instead of shrinking consumption. We are squeezing every bit of these chips. We are taking those gains in hyperscale consolidation, GPU optimization, etc. But those are the easy stuff. The harder is we are now moving toward the physical and the thermodynamic ceilings, such as the Landor limit. Gains continue but slower. Demands rise but faster. Efficiency is no longer reducing total consumption, it's accelerating it. This is the core tension drive the sustainability questions. And for years, we discussed AI in terawatt hours, gigawatts, data center loads. Those numbers are massive, but they are also abstract. They don't tell us what one prompt, one ChatGPT reply, one user action costs. Then, for the first time, Google published prompt level data for Gemini in August 2025, and suddenly we have a microscope instead of a telescope. We have a single Gemini prompt costing us about 0.24 watt per hour, like turning the microwave for 1 second. It costs 0.26 milliliter of water, literally 5 drops, 0.03 grams of CO2, tiny per interaction, invisible at a human scale, but scale is everything. So those numbers, you look at them and you go, oh, they're very small numbers, they're insignificant. But billions of prompts, millions of daily users, that's where drops become rivers and seconds become power plants. The exciting part is the efficiency curve. Google reduced energy per prompt 33 times in a single year. So they actually doing amazing job by reducing the energy. That tell us improvement is real, but also necessary, because usage is exploding faster than efficiency gains. This is the first time we have been able to measure AI like we measure gasoline or calories. And once something is measured, it can be managed. Now we can track progress. We can benchmark. Now the sustainability conversation becomes data-driven, which is very important. Looking at ChatGPT, how bad is really ChatGPT? Although the most sustainability conversation focus on data centers and model training, the dominant long-term driver of impact is everyday inference demand, and that is growing exponentially. ChatGPT now processes approximately 2.5 billion prompts per day. 2.5 billion prompts per day, comparable to 1 billion last year. So the growth is unbelievable. Roughly 300 million originate from the US. The rest is actually globally. Individually, a single query consumes very little energy or water, similarly to a few seconds of appliances usage. It is not meaningful at the micro level. Where it becomes material is in the aggregation. Billions of queries per day translate into measurable load on power systems, cooling infrastructure, and other water resources. This is where personal usage behaves like any other digital habit. Each interaction is small, but the cumulative effect becomes industrial in scale. Energy impact is not primarily a function of per prompt cost, but frequency and scale. When we look at this slide where we compare the global AI data center CO2, you look at where AI is the red on the slide. It's very small actually. So it's not really yet the largest climate burden, and we should recognize that. It's still small relative to the legacy heavy. So why are we worried? We're worried because the trajectory is scary. Traditional industries in this slide, like the steel, like the cement, whatever, they grow very, very slow. But the AI is the compound annual growth driven by inference volume, training cycles, and global expansion is huge. And current growth continue. If the current growth continues, AI could move down this chart very quickly. And when I say go down this chart, that means it becomes much, much larger, potentially surpassing multiple industry sectors within the single decade. So the sustainability challenge is not current footprint, but future acceleration. I have two slides about water usage, and I'm going to move through them very fast. But water cooling is much, much more extremely efficient compared to air. It's actually 3,000 times better than air. And that means water become the natural scaling mechanism for AI. Now, when we look at a lot of our countries in the global south, we have a scarce sources of water, and that could be a huge issue. And then there's three types of water used in AI. We have what we call scope 1, scope 2, scope 3. Scope 1 is the cooling water that evaporates in the building. Scope 2 is the electricity. It's indirect, and it's electricity production itself consume water at the utility level. And scope 3 is actually they use it in the manufacturing. A single semiconductor fab can use 10 million gallons per day, 10 million gallons of water per day when you're making semiconductors. And they use something called ultra pure water production. And that ultra pure water, roughly 40% of the input volume. So you actually got only, if you put water, you only get 40% of it as a pure water that can be used in the manufacturing. The second slide about water is we're talking about the outlook by 2028. U.S. data centers center water use could double or quadruple in less than 1/3 of the facility. Actually, and the amazing thing, only less than 1/3 of facilities track the usage of water. So they all track the electricity, but they don't track water. And we have something called PUE, or power utilization efficiency for electricity. And it's very well developed, and there's a lot of algorithms around it. But we have for water, we have something called WUE, which is water usage effectiveness. And the water usage effectiveness, I mean, it's lagging. Hardly anybody talks about it. And I believe it's because of the abundance of water in the north, and where AI is being developed. But when we move to the global south, this becomes a serious issue. So energy scaling is visible, water scaling is invisible until the taps run dry, and then we have an issue there. When we look at Grok 4 training, I'm not going to spend too much time on this, but basically, Grok is is what Elon Musk AI model is. And they compare it on cost, energy, water, and CO2. And the way I think about the training, because here we're not talking about the inference, but we're talking about the training of the model, which is huge. I think about it, work for training cycle as a way we think about major capital projects. So the upfront compute is essentially a one-time investment. So you similarly to building a cruise ship, and that's the first square on the slide. It shows you how it compares $1.8 billion to build a cruise, $490 million to train Grok 4. And the reason they think about it that way is because when you train Grok 4, then you can depreciate it over time, because every time you do a query against it, you're actually using it. So the asset then depreciated over time as the model is used, refined, and amortized across millions of interactions. So you build it first, spend a lot of capital on it, and then use it for hopefully a couple of years. AI. So it will be interesting how the AI is actually moving as an industry, like steel, chemicals, and transport, and you have to plan the resources around energy, water, compute, and carbon capacity. Here we have the societal and economic sustainability. I have a few slides on this, but because we are way running out of time, I'm going to just basically talk really quick on this. So we now understand the environment constraints, energy and water, etc. But sustainability is only about resources. The bigger question is who benefits, who is left out, and what happens to jobs, knowledge, equity as AI grows. So that leads us to our societal and economic sustainability. We have examined AI as an industrial force powered by electrons, but now we have to look at it as who gets powered by AI. And that's very important because it actually, for the global south, it's extremely important. As I ran out of time, I'm going to just skip through these slides and move to the end, which is what needs to be done. So when we look at the framework, it has to be AI has to be done for based on 3Ps: for planet, for people, and for progress. It's a framework that allow the global south to work through it. And progress is not technological speed; it's a human flourishing over time. We need to plan it extremely well, because it's scary that we're not doing that well. And what we need to do, what we must do, I listed a few actions for us that we have to do. Everything so this is the moment where the conversation must drift into actions. So first, we must design AI that respect physical limits, and we have a lot of limits in the global south. Energy aware, resource efficient, and etc. Second, we have to democratize AI beyond the big tech and the few countries that own it, because that impacts the global south tremendously. And third, we need to put the human well-being back at the center. We should strengthen human creativity, not erode it. It should enhance our agency, not automate it. Progress must be measured by how much it elevates human potential. So we must treat sustainability as the first design constraint, not the last. If we commit to these principles, then AI becomes not a disruption we fear, but a force we guide toward a future where intelligence expand by humanity leads. I'm gonna leave you with an interesting quote. It says, AI will reshape the future, but sustainability determines whether that future is livable. With that, uh, um, I would like to invite, I would love to hear your reflections or questions. Thank you very much.
Thank you so much, Mr. Kateeb, for this really informative and enlightening presentation. This is really great. Please, if you have questions, you either type it in the chat or you indicate by a raise of your hand if you would prefer to speak. So if you have a question, please type in the chat or raise your hand and speak if you prefer to speak. I have a quick question while we're waiting for other questions. I'd like to ask a quick question, Mr. Kateeb. Uh, I think you mentioned about how the two essential metrics you said that define sustainability would be power and water. And considering the situation in the global south, do you think that, how helpful do you think this would be in our developmental efforts, recognizing that power and water are major uh, problems in many parts of the global south currently, and AI is coming in really, really fast. Don't you think that will widen the current issues around equity?
A great question, and I think it's probably one of the most important questions that the global South has to um, address. I mean, we of course we cannot compete with the United States and China creating these large models and competing with them. What we need to do is there is first models that are we call them the small to medium models, which is from 1 billion to 20 billion parameters, and those models are actually more specific to the certain areas like healthcare, education, etc. And what we need to do is we need to use those parameters to actually get in. We cannot sit on the side and getting those two excuses about energy and water. And actually, if we look at some countries as a case studies, India doing extremely well in building their models in India and running like a lot of services. What they do is they take um, models that already built by the West, and they train them on their own data. And I think they did that in Rwanda for healthcare, which is very impressive. They use the local data and the local training. So you don't have to build the whole open AI model but you can actually take one and train it on your own private data for specific things in the global south. The other thing is in the global south, we consider the GCC and MENA global south. They are building tremendous corridors for AI because they're financially capable. And you probably heard about Microsoft investing $15 billion into UAE in Abu Dhabi. It's all going through to AI, and the White House allowed the chips to move to. So different parts of the global South are doing different things. What we need to do is we need to be part of the research. We have to have a strategy around the research. We have to use smaller models, but trained on our data. We have to own our data. We cannot keep shipping the data to the West where their models are getting better using our data, and then they take money from us in licenses. So we're giving them the data, which is I call the data as gold, the new gold. So they're taking all our data, they're improving their models, and then they're charging us licenses to use these models. So we have to figure out how we can actually get around this. I wish I have all the answers, but it's a very complicated issue that we have to figure out.
Thank you so much. That's really helpful. I'm going to read some questions in the chat. There are a few questions in the chat. Uh, Pearl says, thank you for presenting this point of view, but how can we control it all? The global north talks about conservation, but they are still the energy guzzlers. I think she means how can the global south control all of this? How much control do we have over this process?
I think it's that the answer that I gave you is probably address a lot of that part, but I really don't think we can control it. I think we need to be part of the conversation. We need to participate and demand through regulations and governance on how our data is used, how we can. I mean, by the way, huge amount of data comes from our global south to train these models. And right now, we're just giving them with no question asked. So to have to be part of the conversation, I don't like the word control, but to be part of that conversation globally and the governance of AI, we really need to sit on the table and demand that our data is, and then we can also, we need to focus on research. We need to focus on the human talent, all this to be part of it. We cannot control it. We just need to roll with it and be part of the conversation.
Great. There's one other comment. I think this looks like a comment. It says it looks like the countries with centralized economy, that is China, will handle the problems better than pure decentralized, purely private economies. Is not it? This looks more like a comment, right?
Yeah, and I think I really believe there's a lot of discussions about AI being decentralized versus centralized. So the centralized of AI is a bad idea. And because basically you're going to end up few companies going to own it, few countries going to be owning everything. So there are models for AI where you decentralize AI. And if you decentralize it, and you come up with models to decentralize AI, I think it's better for the global south. So decentralization of the models of AI architecture, let's say, should be part of research that we support because the centralization is a bad idea.
Great. There's another question from Dr. Bajo. The models from northern, well, maybe from the north, are trained without giving the real context of the global south countries. How how to build local capacity in AI in global south countries? How to make initiatives, AI models of southern countries sustainable with less government and private funding?
Um, eh, we uh, we lack a lot of resources in the global south. I mean, let's be realistic about it. The numbers that we talk about when when you train an LLM or a large language model, you need a huge capital. You need a huge. I mean, even the chips, the GPUs that are used to actually the training now, the United States is putting limitation on the shipment, and you have to be approved by the White House, etc. So there's a lot of limitations on how to develop it. But I think it's the reason we are in this position is because we are behind in research. We are behind in being part of it. One of the areas I talked about is the distributed AI architecture. If our universities can actually come up with research of how to distribute and use the smaller to medium models based on countries, I think that will help us. So I think we need to invest in how to make AI works for us, not only take that centralized model, that expensive model, and just use it and give them the data and allow them to train their models and be better based on our data. I think we need to be smarter about that.
Yeah, thank you so much. I think these are all interconnected points, really.
Yeah.
I have one other quick question, which you mentioned. You said one of the approaches will be to democratize AI. Can you please explain a little bit more what you mean by democratizing AI and how does that affect the global south?
Yeah, democratization of any technology is basically when you do not allow a central entity control it, either a company, a country, or whatever it is. So democratizing it, you can actually through open source. There are like DeepSeek from China, amazing model that actually caused a lot of issues in 2025 because what it did is gave an open source, very cheap. Any country in the global south can take that model because it's an open source and can actually train it on its own data or use it as is. And it's as efficient as very close to open AI and Google models. So China was able to do an amazing service to, and I found when I visit universities, I found a lot of universities has deep seek on their servers and they use that model. So there is these open source models, and if the more we use it, the better they will be, and we can actually contribute to it. So and this way we can unlock the centralization and the power of of the technology in the hands of the three or four or even five companies in the United States. So I really do believe democratization means uh, open source. Anybody have access to it. It's not IP of owned by any entity.
Great. Another limitation we see very often, especially in our efforts to scale up AI solutions in the global south, is the issue of compute in the global south. How do we deal with this problem and catch up with the fast-moving introduction of AI? I mean, to our benefit in the global south.
Uh, Compute is a huge problem when we talk about the large language models, the huge LLMs. But when we talk about the small and the medium LLMs, which is basically the domain-based models. And when we talk about the domain-based models, it's the healthcare model, it's the government services in Uganda model. It's the model that does a telco in I don't know, Pakistan. Data is trained on. So those models are available, and you can actually use them and train your private data on them. And a lot. And when I talked about Rwanda, that's what they're doing. They're training their healthcare AI initiative on this smaller models. So I believe when we do the compute, we have to focus on these models because I really believe the large models will be a waste of resources and we cannot compete. I mean that's the good answer for it. But we can use what China produced, which is the DeepSeek, and they do the computes and they trained the model and they can give you the model already trained for the general use, and you actually can put it on your servers and you can use it. Now the daily usage is not as bad when it's limited. I mean, the reason why the daily usage is huge is because we have few centralized data centers around the world, and you got over 1 billion people accessing these centralized data centers around the world. So the compute is huge. But if you take a country in the global south and they are doing it services for their own citizens, it will not need the compute powers of servicing 1 billion plus. So I think the distribution or the distributed architecture of AI is the answer here. And we focus on solving smaller problems and breaking it down to smaller problems. And by the way, if we do this, we do the domain-based AI, you will see that you unlock the power of the centralized, because if you have an amazing healthcare AI system and it provides you with all the information and it's much smaller and you can actually run it on servers in a data center in the global south, this is much better answer than using an open AI data center to actually do your healthcare AI.
Thank you so much. This is really helpful. There are a few more comments. We'll just take those very quickly as we try to round up. Uh, from Alindo, we need to define AI strategy at country level, regional level, and continental level. Many countries don't have AI strategic plan. How to solve the problem? How do we solve the problem?
What's the problem? Sorry.
The
Each
issue
country
of
develop.
developing AI strategic plan.
I
How can
agree.
we?
I
Yeah.
don't think it's a problem to have each country have. I mean, you have to develop an AI strategy per country, but you have to look at best practices worldwide. So you have to see what the world is doing, and then the governance. You have to own the governance. You have to own. Look at what Europe is doing. Like Europe is not following everything that the US is doing. They have their own standards and governance and all that on data protection and etc. So I do believe that we should all think in each country should think about their AI strategy, but we should look at the best practices around the world, like any technology. We look at best practices and we import those best practices and see if they fit our governance or not. If they do, then we use them. If they don't, then we don't use them. So I don't think it's a problem. I think each country should be involved internally in that discussion of what is our AI strategy, how this country is, and because as you know, the strategy has a lot of components. It's not only how to use an LLM, but AI strategy could be in the universities, what's the strategy and the research strategy, and in the government and the usage of that, how you govern that AI, and then how the citizen can use it, and then the private businesses and what the private businesses can do with AI. All that I definitely think is not a problem to think of it on the country level.
Thank you so much. That's quite illuminating. I think the others are comments. Professor said, do you want to speak to your comments? You don't seem to be convinced that decentralization is possible. Professor Serge, you want to speak to that briefly for a couple of minutes?
Okay, I'm now coming to the screen. Um, you see, question is high tech by definition is centralized. How many countries send in satellites? Half dozen, 1 dozen. How many countries produce planes? How many countries produce submarines or whatever? So even when we talk about um, AI, how many countries produce chips for AI? So by default, we operating in environment which is where big basically conglomerates are defining things, and freedom for operations is somewhat quite limited. Therefore, decentralization is okay on applicational level, but at the end of the day, what can be done if at the end of the day, sort of Big Brother will control entire chip production. and control everything. After that, sort of you can decentralize whatever you want, but they have the power. So a point, I share with you that we supposed to be somewhat, sort of trying our portion, and I try to figure out how it can be achieved. Because, say, in today's world, it's happened like that, sort of
Yeah.
NVIDIA producing chips and Intel and few Chinese company, TSMC, whatever. The rest are basically just user.
Yeah.
And example of Snowden show us that it's actually possible to have Big Brother.
I mean, yeah, I mean, valid point, but the problem is this is what I call like the vicious cycle of technology, where basically it starts in certain specific countries and they own it and they own the IP, and we just not a contributor but an owner, sorry, not a contributor but a user of the technology, and we keep using that technology, and we still pay Office license, and we Windows license and this license. This is a vicious has been going on for 60, 70 years. Now it's the question is, should the internet, should the AI be just another cycle where we give it away and we accept what you're just saying, which is basically, okay, yeah, they own everything, we'll just do it? Or should we break that cycle, think about a way to break that cycle? If you look at the internet, I believe the internet is a very good example. It's a great technology, but it's not, by the way, internet is not really centralized, as you know. I mean, servers for the internet are all around the world, and the contribution to the internet is all around the world. Yes, major companies who are do commercial business are in specific are Americans or Europeans, but and the global south is not really as big as Amazon.com, but still the internet servers in each of the global, you find internet servers in each of our global south countries. You find contribution to the internet in all south countries. So it is, how long can we wait for the AI? The AI is just in the beginning, by the way. I mean, it's only 3, 4 years old. The generative AI, I should say, not the AI. AI has been available since the 50s, the 1950s. But generative AI, which is the whole craziness going about it, it's only 3 to 4 years old. First paper was written on it in 2017. That's meaningful paper. So I do believe that I mean it is a hard issue to tackle, but I believe we should tackle it. I don't think we should just accept it, sit and accept the centralized model. And I think China did an amazing job by not accepting. By the way, as you know, China has not played a very big role in the previous commercial technologies, and that nobody's using Chinese software on any of these countries. But if you look at what they did for the AI, which is basically they decided, it was a decision, we're not going to sit on the side and watch what the US is going to do with AI. And they did an amazing job with DeepSeek. And I think the models will continue to evolve. Now we have one from Alibaba, and more are coming. So I believe we should look at what China did and see how we can partner with China and cooperate and get into the discussion.
Great. Thank you so much. I think the other comments in the chat are just comments, and we
Just
take
quick
note of them.
quick
Our
response
time.
on that. You see, when I totally agree with what you say, but when I come to shop and I can buy only China-made garlic in Australia, New Zealand, which have a lot of land, and here in Malaysia, because China produces 70% of all garlic sold in the world. That is, what worries me. So globalization, in many sense, started to dictate us what we're doing.
I
Yeah.
agree. And I think just as you're worried about the products coming out of China as manufactured in China, you should worry about AI, because that's why I said each country should have their own strategy and their own governance. AI is really, I believe, it's the most powerful thing happened to humanity since electricity. I believe it's gonna impact every single thing we do in life, and I believe it's gonna change us as humans. So I don't think it's we can take it lightly as only a product like a car or whatever. I think it will go deep into the family, the society, the human definition, and that we should definitely in the global south have something to say with it. Or AI, if we continue to use these centralized model, we will lose our language, our culture, our norms, and our values, because it's all will be trained in in the US or another country on their values, on their, which is good for them. I'm not saying it's bad for them, but for us, we still have our own values and our own norms and our culture and our language, and we definitely need that to be in AI too. So that's where I come from.
Thank you so much. And that's how we're looking at it at AI for PEP. We're focusing on generating data from our communities and using that to train the models that will be useful to the health system in our communities. So I'd like to really thank Mr. Kateeb for this excellent talk. This has been really, really interactive and illuminating. And I really want to thank you for your time and for your expertise in giving this talk. So, ladies and gentlemen, we have come to the end of this session, and I thank all of you for joining today. We keep in touch for the next lecture series. Thank you so much, Mr. Katib, and thank you to everyone